more than 100 billion kilowatt hours of clean electricity every year. Nearly 20,000 hectares of dry land have been restored, and desert areas that were once nothing but sand are now home to grasslands and grazing livestock. It sounds like the result of several different projects, but in China, all of these achievements come from a single project. For years, this area was a barren land marked by sandstorms, extreme heat, and worsening desertification. Yet instead of trying to turn the desert into farmland, China took a very different approach, covering it with millions of solar panels. What is surprising is that these panels do more than generate electricity. They also help plants grow, support livestock grazing, and gradually transform the entire ecosystem beneath them. So how does this ambitious model work? Let's find out on Mandarin Tech. Behind the vast solar panel fields spreading across China's deserts is agrivoltaics, or agri-PV, a concept first proposed by two German scientists in 1981 to combine agricultural production and solar power generation on the same piece of land. However, for decades, the idea received little attention. It was only when demand for clean energy surged and agricultural land became increasingly limited that agrivoltaics emerged as a solution pursued by many countries. For China, the technology arrived at exactly the right time. As the world's largest manufacturing economy, the country consumes more than 10 trillion kilowatt hours of electricity every year, with around 6 trillion kilowatt hours still generated from coal. When Beijing set a goal of achieving carbon neutrality by 2060, expanding renewable energy became an urgent priority. At the same time, China could not afford to sacrifice land needed for agriculture. As a result, agrivoltaics quickly became a highly promising solution, allowing electricity generation and agricultural production to coexist within the same area. Before the first grasslands appeared and livestock could graze beneath the solar panels, engineers had to overcome a much bigger challenge: the desert itself. Unlike traditional solar farms, where panels are installed low to the ground and placed close together to maximize power generation, agrivoltaics must serve two purposes at once. Beneath the panels will be crops, agricultural machinery, and livestock. As a result, the entire system must be built higher above the ground and designed with a completely different structure. But building in the desert is never easy. The ground consists of loose sand that constantly shifts under the force of the wind. Massive earth-moving machines cut down high sand dunes and fill low areas to create a more stable surface. Once the site is prepared, hundreds of thousands of steel piles are driven 1.5 to 3 meters into the ground using specialized hydraulic pile drivers. Every location is positioned with GPS and laser systems to ensure near-perfect accuracy. At some of the largest agrivoltaics projects in northern China, the total number of steel piles can reach 1 to 2 million. On top of this foundation, galvanized steel beams and high-strength aluminum structures rise above the sand, connecting together to form enormous frameworks stretching to the horizon. They must support millions of solar panels while withstanding winds exceeding 120 kilometers per hour and extreme temperature differences between day and night. Not long after, the bare steel frameworks standing in the middle of the desert were covered with millions of solar panels, transforming the landscape into a vast ocean of energy. The panels are manufactured at multiple factories and then transported to the construction sites on a massive scale. There, installation crews use specialized equipment to lift each module onto the supporting structures and secure them with aluminum clamps and corrosion-resistant bolts. The panels are then connected into long electrical strings, collecting direct current and transmitting it to inverter stations distributed throughout the project. At first glance, this looks little different from a conventional solar farm, but the unique feature of agrivoltaics lies in the way these panels operate. At many large-scale agrivoltaics complexes in Inner Mongolia, the solar arrays are mounted on single-axis tracking systems. From sunrise to sunset, the entire rows of panels continuously rotate to follow the sun, maintaining the optimal angle for energy collection. This solution increases electricity generation by 15 to 25% compared with traditional fixed panel systems. More importantly, this movement provides another benefit that few people would expect. By adjusting the tilt angle of the panels, engineers can control how much sunlight and shade reaches the ground below. Instead of simply generating electricity, these enormous solar arrays are gradually becoming smart canopies, creating a more favorable environment for crops to grow in the harsh desert landscape. But for these smart canopies to truly generate more than 100 billion kilowatt hours of electricity each year, an equally massive infrastructure network is required beneath the vast sea of solar panels. Hundreds of kilometers of cable trenches are excavated across the desert, connecting individual solar arrays into a power network that stretches across thousands of hectares of land. From here, electricity generated by millions of solar panels is continuously collected and begins its journey out of this remote landscape. However, the electricity produced cannot be sent directly to the national grid. Throughout the project, dozens or even hundreds of inverter stations are strategically distributed to receive power from the solar arrays. Here, direct current is converted into alternating current, preparing it for long-distance transmission. Further out within this ocean of energy, enormous substations begin to appear. Viewed from above, these facilities resemble command centers, surrounded by solar panels stretching all the way to the horizon. From these substations, electricity is transmitted into high-voltage power lines and integrated into the national grid. What stands in the desert at this point is no longer just a solar farm. It has become a gigantic energy complex capable of delivering clean electricity from remote wastelands to China's largest economic centers and supplying power to millions of households. Clean electricity is now flowing into the national grid, but the ambition of agrivoltaics does not stop there. Most of China's agrivoltaics complexes are built in the arid regions of Inner Mongolia, where surface sand temperatures can exceed 60 degrees Celsius during the summer. Under these conditions, much of the water evaporates before it can penetrate deeply into the soil. To grow plants successfully, engineers first had to change this environment. Hundreds of kilometers of drip irrigation pipes are installed beneath the solar arrays, delivering water directly to the root zones instead of spraying it across the surface. At the same time, the soil is enriched with organic fertilizers, soil amendments, and beneficial microorganisms to improve moisture retention and restore fertility. Once these basic conditions are established, the real process of desert greening can begin. Areas beneath the solar panels are planted with species that can thrive in arid environments. During the initial phase, drought-tolerant forage crops such as alfalfa, ryegrass, and various native grasses are typically prioritized because they help stabilize the soil, reduce erosion, and gradually improve soil quality. If plants can grow beneath solar panels, could these vast desert areas one day become enormous agricultural fields? The idea is not as far-fetched as it may seem. In the United States, many agrivoltaics projects have successfully tested crops such as tomatoes, peppers, lettuce, kale, and various other vegetables. Some studies have even found that yields of certain crops were maintained or improved, while irrigation needs were significantly reduced thanks to the shade provided by the solar panels. However, in northern China's deserts, the immediate priority is not yet maximizing food production. The first goal for engineers is to restore the land beneath the panels. Only after the soil begins retaining more water, vegetation becomes more stable, and growing conditions improve do many projects expand into higher-value crops such as licorice root, goji berries, and astragalus. These crops are not only well adapted to arid conditions, but also generate far greater economic value than the grasses originally planted for land restoration. The growth of vegetation beneath solar panels not only helps restore the land, but also opens up an entirely new way to utilize it. At many agrivoltaics complexes in Inner Mongolia, these areas are gradually being used as grazing land, with flocks of sheep appearing between rows of solar panels that stretch all the way to the horizon. At first glance, combining livestock farming with one of the world's most advanced energy systems may seem unusual. In reality, however, the two models complement each other naturally. Solar panels are typically installed at heights of 2 to 5 meters, creating large shaded areas that help livestock escape the intense summer heat. Meanwhile, the grass growing underneath becomes a readily available source of feed, without requiring any additional grazing land. An adult sheep can consume between 2 and 4 kilograms of grass per day. With flocks numbering in the thousands, vegetation is continuously managed without the need for lawnmowers, fuel, or additional maintenance workers. Reducing the accumulation of dry plant material beneath the panels also helps lower the risk of fire during the dry season. In addition, livestock manure is returned to the soil, adding organic matter and nutrients to an ecosystem that is gradually becoming more stable. The value of this model goes beyond reducing operating costs. Inner Mongolia is currently one of China's largest sheep farming regions, with total sheep populations regularly reaching tens of millions. Integrating livestock farming into agrivoltaics projects allows many local communities to generate additional income from meat, milk, and wool production, alongside revenue from electricity sales. As vegetation became more established and grazing continued over the years, even larger changes began to appear. In some restored areas, the number of recorded species increased from fewer than 100 to more than 530. According to international assessments, roughly 1/3 of Inner Mongolia's desert regions have now been restored or regreened to varying degrees after decades of rehabilitation efforts. Seeing this potential, China has made agrivoltaics part of its national anti-desertification strategy. Under current plans, the country aims to deploy about 253 gigawatts of solar power across desert regions between 2025 and 2030, while restoring around 7,000 square kilometers of degraded land, an area nearly 4 times the size of London. But the value of this model is not measured only in kilowatt hours or hectares of restored land. As these agricultural areas begin producing stable harvests, they also create new sources of income for local communities. Goji berries alone have grown into an industry worth about $4.2 billion annually in China. What makes the system even more interesting is that its benefits work in both directions. Vegetation helps stabilize the soil and reduces the amount of dust carried into the air by the wind. Less dust means cleaner solar panels, lower maintenance needs, and more stable power generation over the long term. As a result, this is not just a massive energy project. It is a system where clean energy production and environmental restoration support each other. Although China is deploying agrivoltaics on an unprecedented scale, the model has taken a different approach in the Netherlands. A 4-hectare raspberry farm has been combined with a 2-megawatt solar power system. The solar panels are installed above the raspberry rows, completely replacing the plastic covers that were traditionally used to protect the crops from hail and extreme weather. At first, many people were concerned that the shade cast by the solar panels would reduce crop yields. However, both the quality and productivity of the raspberries remained largely unchanged. During some periods, crop performance even improved thanks to more stable temperatures and better moisture retention. During summer storms, the rows of solar panels act as a strong protective shield above the crops. In addition to protecting the harvest, the system also reduces irrigation demand by up to 50% during dry periods by limiting water evaporation from the soil. The project quickly became one of the most convincing examples of the potential of agrivoltaics in Europe. Success stories like this have helped encourage many countries to adopt the model more confidently and expand it on a much larger scale. If agrivoltaics offers so many benefits, why haven't China's deserts already been completely covered with solar farms? The biggest reason is the cost and complexity of the system. Unlike conventional solar power projects, which focus solely on generating electricity, agrivoltaics must also support crops, vegetation, and in many cases even livestock farming. As a result, these projects typically cost about 10 to 20% more to build because they require taller mounting structures, wider spacing between solar panel rows, as well as irrigation systems and additional supporting infrastructure. For complexes covering thousands of hectares, these extra costs can amount to hundreds of millions of dollars. The challenge is not limited to the initial investment. Engineers must constantly balance power generation, crop lighting requirements, water availability, and ecosystem restoration goals. If any one of these factors fails to perform effectively, the benefits of the entire system can be reduced. This challenge becomes even greater in the arid regions of northern China, where rainfall is limited and water is always a valuable resource. As a result, every project requires long-term investment in a far more complex operational strategy than a conventional solar power plant. Even so, China continues to expand this model on an increasingly large scale. Throughout most of human history, deserts have been seen as the limits of life. But the story of agrivoltaics shows that value does not always come from finding better land. It can come from finding new ways to create value from the land we already have. Millions of solar panels can generate electricity. But what is even more remarkable is that they are creating an entirely new way to produce energy, food, and economic value on the same piece of land. And if deserts can be revived in this way, how many other landscapes around the world are still waiting to be awakened? Share your thoughts in the comments below, and don't forget to subscribe to Mandarin Tech for more incredible technologies in mega projects from around the world.